So today we are adding to our notebooks equivalent forms of inequalities, and that is page 18. Okay, so it's 2 pages. You should have the first page, which is the title on the left-hand side, and then the second page over here on the right-hand side. So pause it if you need time to put that in, but here we go. So when we are talking about equivalent forms of inequalities, we're talking about inequalities and the different ways that each of them can be represented. Okay, so we should know at this point that we have 4 different types of inequalities. Okay, we have a greater than. Okay, we have a less than. We have greater than or equal to. I guess I should have made this box bigger. And less than or equal to. Okay, I think my students know that these 4 exist, but sometimes I get the students go, oh, it's an alligator that opens this way, or they try and show me with their fingers which way they want it to go. I want you to absolutely know which inequality is what. Okay, so if we are talking about greater than, oh dear, that's gonna soak through my paper. We are talking about an inequality that goes this way. If we are talking about less than, we are talking about an inequality that goes this way. And the biggest thing that I can tell my students is that less than is sort of the same direction as an L, right? So this is the direction of our inequality symbol, which is slightly like an L, right? So that's our less than. Greater than or equal to is the same as greater than, but it has the line underneath it. And less than or equal to is same as the less than, but again, the line underneath it. Okay, and we can talk about these with numbers, symbols, whatever. Okay, so if I say something like x is greater than 4, I'm talking about all of the different numbers that are greater than or equal to 4. Oh, no, not or equal to, just greater than, that are greater than 4. So 5, 6, 7, 8, but that can also be 4.1, 4.11, 4.111. So, right, I could do that all day. So each of these have an infinite number of values. There are so many things that x could be, we cannot write them all down. Now, it doesn't always have to be the letter x. So we could have something like y is less than 2. Right? Y could be 1, 0, -1, but it could also be 1.9, 1.99, 1.999, 1.99999, right? Same idea. I could list that forever. It can be with negative or positive numbers. So A is greater than or equal to -7. It could involve fractions or decimals. It could be less than or equal to 1/2. So it really can include anything in there. Okay, now we can also do this just straightforward with numbers. We can use these symbols just like you've done in middle school or even younger, right, in the intermediate building. So you could say something like 7 is greater than 5, right? This symbol is telling us that 7 is larger than 5. Okay, so now here's one we worked on when we talked about number lines, right? We could say -3 is less than -2. Right, that one seems kind of backwards, but remember with negative numbers, they are that way. Now, greater than or equal to, we could even use the same number, right? So we could say 5 is greater than or equal to 5 because it is also equal to. But it doesn't have to also be equal to. So by the same concept, right, I could say 3 is less than or equal to 10. Right? Really anything will work in there as long as you make sure it's a true statement with that inequality symbol. Now, we can also represent these things on a number line. So that's one more option we're going to sort of add down here as well as we talk about this. Okay, so if we have the algebraic form of x is greater than or equal to 8, okay, it's kind of hard for me to have this without saying the words, right? We could look up here and replace this symbol with the words that go with it. So that would be X, right? We could say X is greater than or equal to 8. Now, I guess I should write this up here because whenever we truly write this down, we always put the word is in here. So this is really is greater than, is less than, is greater than or equal to, is less than or equal to. Right? It's a greater than sign, but when we're talking about it in words, that is might help you to actually write it down in sentence structure form. If we want to graph an inequality on the number line, okay, we have some rules that we go by. And the rules tell us that if we have this line underneath it, so anytime we have an or equal to, okay, that means we are going to put a filled in circle, a solid circle on our number line. So if we have that or equal to, we want a solid circle. Okay, we also know that anytime it is greater than, we are going to shade to the right. So if I want to translate this onto the number line, I'm going to use my number line rules. I don't need you to put every number that ever existed on the number line. So just give me a few. So if we have 8 in the middle, put this number in the middle. And as long as I have one number to the left and one number to the right, I don't need everything else. Okay, this has an or equal to. So this says at 8, used a solid circle. That tells me that 8 is a number. 8 is greater than or equal to 8. I could use 8 as a number. And then I can use any number that's larger than it. So I'm going to shade over here to the right. Now notice how I'm being very clear with my shading. I don't need you to make a ginormous circle, but also don't make a super teeny tiny one that's impossible to see. You don't need to scribble everywhere, but make sure it's clear where your shading is at. Okay, an equivalent inequality would mean that we can also represent this inequality with that variable on either side. Okay, so it's fair to say x being greater than or equal to 8, but that is the exact same thing as writing the 8 first and the x second, right? But the 8 is still small. Well, the 8 was the smaller one, right? The x was larger, the 8 was smaller. So I still need to represent that same thing by showing which one is larger. You always want the inequality to be opening towards the same thing it was opening towards before. Now, this is the better option of how to write it. Right? That variable being first is the better option, but these two are the exact same thing. They mean the same thing. Okay, so let's look at this in some other situations. Okay, let's say we have all real numbers less than 15. So we want all of the numbers less than 15. Okay, so all real numbers is telling us that we can pick any variable. X, Y, let's pick a different one. Let's pick W. And we want to do less than. Okay, so we're going to use our less than symbol. The number 15. Our equivalent form is just going to be the flip-flop of this, right? That's what we were just saying. So I could put that 15 first and that W second, but that means I'm going to have to flip my inequality sign. So if W is less than 15, that's the same thing as saying 15 is greater than W. To put that on the number line, I'm going to need 15 on the number line, right? And then 1 to the right and 1 to the left. Now this piece, we didn't talk about it yet. If there's not an or equal to, okay, then this is going to be an open circle. So at 15, we are going to use an open circle. And if it is less than, we are going to shade left. Okay, so now the question is, do I use this form or do I use this form, right? Because this has less than and this has greater than. We can only graph from the situation where the variable is first. Okay, so we need that variable first to be able to translate those words. W is less than, so because that is less than, we are shading to the left. Because numbers less than 15 are 14, 13, 12, 11, 10, and so forth. Okay, so now if we look at this next situation and we're given -4 is less than m, we definitely can't go to graphing because we know to graph, we need this to be in its other format, right? We need the variable first. So same thing, right? We're switching the order. And once we switch that order, that sign switches with it. Okay, so if we want to translate this onto our number line, now we're good because now the variable's first. So be really careful here. My number to the right is -3. So this one is not an or equal to. So just like we said up here, when it's not or equal to, this gets an open circle. And when it's greater than, right, we said that on our first page, when it's greater than, we want to shade to the right. But again, if we think about that, numbers greater than -4, numbers greater on the number line are always to the right. Another way that my students like to think about it is they like to sort of draw a little arrow in here, right? So if you can imagine there being a line in here that makes an arrow that's pointing the direction you need to shade. Okay, and then in our written form, we could either say m, x, whatever, pick a variable. Or we could also say all real numbers. Either way is fine. So if we say all real numbers, right, because that's what a variable represents, all the numbers. Okay, and this symbol, right, if you're not for sure, flip it over and look at your table, is greater than. So all real numbers greater than -4. And then our last one here that we have, so we're given this graph to start with. Uh-oh, we need a number in here. Let's just make that up to be a 2. You don't need all those numbers. Let's just put in 2. Okay, so let's see if we can go this way. If this is a filled in circle, we said we know we need it to be an or equal to. So it has to have an or equal to. And it's shaded to the left. So let's see, we said greater than is shading to the right, less than is shaded to the left. So this would have to be a less than because it goes to the left and an or equal to because it's a filled in circle. We can fill in whatever variable we want, and that is at 2. Okay, so this would say y is less than or equal to, that's the sign we picked. Number 2. And our equivalent form would be to flip-flop these two. And we said when we do that, we flip the sign with it as well.